Hey, ChemStars, this is Mrs. Vanderlei bringing you another edition of ChemStar video for section 7.3. We have learned how to factor label. We spent a couple days learning how to factor label, and we're going to continue using factor labeling to help us interconvert between particles and moles, okay? So our vocabulary for this section will be moles, molecules, atoms. You should know what an atom is. We learned about that in chapter 3, like one atom of carbon. And this one called Avogadro, excuse me, number. It's not the vegetable avocado or avocado, it's Avogadro. Anyway, it says to open the section, each year contestants from all over the world travel to Harrison Hot Springs in British Columbia to compete in the World Championship Sand Sculpture Contest. Each contestant creates a beautiful work of art out of what? Out of millions and millions of tiny grains of sand. You could measure the amount of sand in a sculpture by counting the grains of sand. But is there an easier way? All right, so what is our goal in this little scenario? How many grains of sand? All right, so measuring matter, we're asking for how many, in this case, things. All right, things could be sand particles. All right, and the question is, how are you going to do this? How are you going to figure out how many sand particles are in your beautiful sand sculpture? So the question is now, are you going to count them individually? Well, I'm going to write this. Oopsies. Hello. I hope not. All right, that would take you for the rest of your life. So that wouldn't make a whole lot of sense. So how could we measure the amount of sand particles in your thing? Well, you could count them individually. All right, don't recommend that, but you could, okay? Well, what would be easier? So think about this. If you were given the task of finding out how many sand particles are in this sand, sculpture, what are you going to do? Well, you can do a couple things. Maybe you'd count out maybe 100 grains of sand, take you a while, but you could do that and do what with that? And maybe take their mass. So then you could set up a proportion. Oh, maybe you could factor label, and you could figure out, well, if I had this amount of mass, and I know that 100 grains have a certain mass, I could figure out how many grains are in the whole thing. What else could I do? Maybe you don't have a scale that big, but maybe your little sand pails you knew were exactly, 1 liter. So could you take perhaps the volume, maybe take the volume of 100 grains of sand, and then figure out with your sand pails, sand buckets, how much volume you have, and then you can figure out how many particles. It'd be a whole lot easier counting out 100 sand particles than the entire thing of your sand sculpture. So what does this mean? I can use things like mass, and I can use things like volume to figure out how many exact particles, or pretty close to exact anyway, how many particles, how many things you have, okay? So where is this going? Well, let's find out. So back in the early part of chapter 2, we talked about the SI units, the metric system. And the SI unit for the amount of stuff was a mole, okay? So now we're going to actually talk about, well, what is a mole? A mole is a number, okay? So like a pair, hey, you all know what a pair is. If I say you can have, a pair of shoes, you have 2 shoes. I said you can have a dozen cookies, that's going to be yummy. You have 12 cookies. You might have heard about a score. Remember Lincoln's Gettysburg Address, 407 years ago, our fathers founded a nation. What was a score? Well, a score was 20. So when Lincoln said that 407 years ago, he's saying 87 years ago was in 1776, I believe. And so it was 87 years ago from the Gettysburg Battle that, our forefathers founded a new nation. So a score is 20, okay? So we can have, like I said, a word that represents a number. So a mole represents 6.02 times 10 to the third particles and is the SI unit for measuring the amount of a substance. This number is also called Avogadro's number. However, Avogadro did not come up with this number. Avogadro found that there was a relationship between the volume and the number of particles. Avogadro did not really know how many particles that was, but he just knew the more particles, the greater the volume. So J. Perrin from France first used this Avogadro's number to describe the number of particles in a mole. So then, you know, if Avogadro was alive at that point, which he wasn't, he had passed away when Perrin came up with this, that they said, well, instead of saying the number of gas molecules make up this balloon, he could have an actual number, 6.02 times 10 to the 23rd, okay? So therefore, 1 mole is 6.02 times 10 to the 23rd things, all right? Let me pause here. All right, so I have some analogies for you, all right? So how big is this number truly, ready? If there were a mole of rice grains, if there were 6.02 times 10 to the 23rd rice grains, all the land of the area of the whole world would be covered with a rice to the depth of 75 meters. But the problem is 1 mole of rice grains is more grains than all the grains of rice that have ever been grown since the beginning of time. So we could never actually do this. 1 mole of rice would occupy a cube of 120 miles on one edge. So imagine a cube 120 miles in all 3 directions, okay? Computers can count at the rate of 80 million counts per second. At that rate, it would take a computer over 25 million years to count 6.02 times 10 to the 23rd. All right, a mole of marshmallows, catch this, would cover the United States to a depth of 600 miles. So they would cover the earth, or at least, yeah, the whole land area, 600 miles tall. Can you imagine how many s'mores you could make with that? All right, what about this? In order to put a mole of raindrops in a 30-meter diameter tank, which is about 100 feet, the size of the tank would have to be 208 times the distance from the Earth to the sun. Think about that. I'll say it one more time. In order to put a mole of raindrops in a 30-meter, which is about a 100-foot diameter tank, okay, the sides of the tank would have to be 280 times greater than the distance between the Earth and the sun, all right? So it says, how about this one? Assuming each human being has 60 trillion body cells, that's quite a bit, and the Earth's population is about 6 billion, give or take a few, the total number of living human body cells on Earth at the present is about 3.6 times 10 to the 23rd, or a little over half a mole. So there are 6 billion people on the Earth, and each person has 60 trillion or 6 trillion cells. You add up all those cells, we only have a half a mole of cells, okay? I think you get the point here. So how big is this number? Well, it's this big. Well, how big is this? Well, follow me, all right? This is the thousands. This is the millions. This is the billions. So every person is about this is billion. This is trillion. 6 trillion cells. What's after trillion? Quadrillion. This is quintillion. This is sextillion. All right, so it's 602 sextillion things. All right, so that's how big that number is. Okay, so why in heaven's name are we talking about such a huge number? If we had that many marshmallows, I know we'd all suffocate. All right, we could never eat that many s'mores. If we had that many rice grains, well, we've never had that many rice grains. Why do we need that large of a number? Well, because an atom is that small. Okay, so let's check this out. Okay, so what's carbon? Carbon's an element. So what is the basic unit of an element? Well, it's an atom. So the chemical formula is C, right, just carbon. And you have 6.02 or 602 sextillion atoms in 1 mole. Notice that this word is an atom. Well, what's nitrogen gas? Isn't that N2? Well, what's N2? Well, it's a diatomic molecule, isn't it? My chemical formula is N2. Well, that means there are 6.2 times 10 to the 23rd molecules in 1 mole. So that's the smallest unit of nitrogen gas. It's a molecule. Well, what about copper ion? I just made it copper plus, all right, plus 1. It could be plus 2, I don't care. But you have 6.02 times 10 to the 23rd ions in 1 mole. What about calcium fluoride? It's a molecule, all right, or it could be a formula unit. Its chemical formula is CaF2. You should remember that from the last part of chapter 7. And guess what? There are 6.02 times 10 to the 23rd molecules or formula units in 1 mole. And what's water? Well, water is definitely a molecule, all right, and it's H2O. So there are 6.2 times 10 to the 23rd molecules in 1 mole of water. So what do you notice? Look at the units here. Are they all the same? Not all of them. I got 3 of them are molecules, but no, they're not all the same. You can have a mole of anything, but what would make the most sense? Only something that is teeny tiny, teeny tiny. All right, and then the numbers make sense. Okay, you can't have a mole of pennies. All right, we would just drown in copper. Okay, so you need something really, really small in order to use a number that big. So that would represent 1 mole. You can have a mole of pennies, but why bother? Okay, let's go to the next page. All right, so we need to learn how to convert number of particles to moles, all right? So guess what? We are going to factor label once again, all right? So it says, how many dozen apples are in 90 point? I put a little point there. Maybe you can do that too because it'll have 2 sig figs then. How many apples, all right? So what are we looking for? Remember how we factor labeled? We're looking for how many dozen apples, all right? Hey, what am I given? I have 90 apples. What do I do next? I need to draw this line. You remember that? And now what? What unit must go on the bottom? Apples, right? Apples go on the bottom. And what goes on top? What unit am I looking for? Do I know a relationship, the number of apples and how many dozens I have? Yeah, I do. It's 12 apples are in 1 dozen. Okay, so now what? Hey, what can I do at this point? Can I cancel things out? I sure can. Apples cancels out. What unit is left? Dozen is left. That's what I'm looking for. So I am ready to divide. By the way, get out your calculators. You're definitely going to need them. Definitely going to need them, all right? So what did you get when you did that? I'll let you pause. Boom, 7.5 dozen. Hopefully you did that. Now, if you did not get out your calculators yet, do so now. I'll pause this, or you pause this, and get out your calculator. You truly, truly need this, okay? I'm not lying. Go ahead and pause this. Get out your calculator. All right, welcome back. So this time, what are we trying to do? How many moles are in 1.25 times 10 to the 23rd atoms of nitrogen, all right? So what's my given or what's my unknown? I'm looking for moles. There's my given. Now what? I need a line here. What unit must go on the bottom? Atoms. There are 6.02 times 10 to the 23rd atoms in 1 mole. So there are always 6.02 times 10 to the 23rd counting things in 1 mole, and you can count individual atoms, all right? And now it's time to what? Well, I'm going to take my red marker here. I'm going to cancel out atoms. I'm going, oh, look at this, moles are on top, and isn't that what I want? Yes. Oh, by the way, you abbreviate mole by dropping off the E. The MOL is your accepted abbreviation for mole. Very clever. You save yourself a letter, okay? So now what? I'm going to divide, right? But I have exponents. So this is what I want you to do. So this is the best I could do to show you your calculator. So you're going to divide, okay? Ready? This is what I want you to do. Follow along. Use your calculator to do the same thing, okay? Ready? So press 1.25. And this is the important part. Do not do times 10 with a caret. You will get it wrong. Okay, did you hear me? Do not use times 10 caret. You will get it wrong, especially when you divide. Okay, are you ready? So 1.25. Now go up here, your second, and do you see this button right here? EE. Do you see the EE? Second EE. And I think it was 23, wasn't it? Okay. Then what? You want to hit your divided by 6.02 second EE 23rd. I'll say it again. 1.25 second EE 23 divided by 6.02 second EE 23. Now, if you have a different calculator, look for an EXP button. Often it's down in this little corner someplace over here, all right? It might be over here. I'm not sure about your individual calculator, all right? So if you cannot figure out where your exponential button is, make a note and ask your teacher first thing the next day, all right? So make sure you use that second EE button, okay? And so what do you get? If you haven't done it yet, use your calculator and figure it out. Just don't wait for me to do it. You need to know how to do this. Okay, this is what I got. But wait a minute, Mrs. Vandeweghe, it's overkill. I don't need the entire calculator display for my answer. Go back and look at your sig figs. I have 3 sig figs, so I'm going to condense this to 3 sig figs. That's my answer. All right, let's look at the next question, number 3. All right, so how many moles are in 2.80 times 10 to the 21st? So how many moles are there in 2.80 times 10 to the 21st molecules? I have to factor labels, so I need this next, don't I? What unit must go on the bottom? Molecules, all right? So folks, that number, is still equal to 1 mole. Notice how the one up here was atoms, and now this is molecules. It makes it, what's the smallest unit of the element nitrogen? It's an atom. What's the smallest unit of the H2O? It's a molecule. It's still the same number, all right? So now it's time to divide again, all right? Let's go look at my calculator again. So what am I gonna do? I'm gonna go 2.80 EE, second EE, there you go. I think it was 21st, wasn't it? Divided by 6.02, second EE, 23. Hit your equal button or your enter button, all right? And then you try it and see what you get. Go ahead and do that. All right, so this is what I got, 0.00465116271 or something, all right? Mrs. Vino, that's overkill, I know. So I have 3 sig figs here. The zeros, they are not significant, all right? So start with the 465. Do I round up? No, I don't. So there you go, that's how many moles I have. Why don't you try number 4? Start from the beginning, question mark, whatever, and get your answer and then see how you do. So pause this, please. All right, how'd you do? Welcome back. So how many moles are equal to this many ions? Notice I have a different unit here, ions, molecules, atoms, but it's still the same number, isn't it? So we have this many ions are equal to 1 mole, all right? So this is what I got when I punched out my numbers. I have 3 sig figs again, so I need 3 sig figs. Folks, these are just made up problems. They won't always have 3 sig figs, but these do, okay? All right, so let's see what's next. All right, so now you're gonna convert moles to particles, all right? So it can be atoms, it can be moles, or whatever. So if the particle of the is an element, you have always, whoa. Okay, welcome back. That was weird. So you always have like 1 atom per molecule. So if you're looking at just molecules and you're looking at atoms, it's still at 6.2 times 10 to the 23rd, all right? So how many atoms are in 3 moles? Oh man, it's 1 sig fig. I hate 1 sig fig. All right, so now what? I need this times button. And now what? What unit must go in the bottom? moles. How many particles, how many things are in 1 mole? 6.2 times 10 to the 23rd. Why do I use atoms? I'm talking about the element of carbon. All right, so now go back to your calculator, and what is 3 times 6.02 second EE 23? Now be very, very, very careful. Whenever you're using your exponential button, look at your calculator display very carefully and make sure you see the end part of it. So always look and see if you have an exponent as part of your answer. Did y'all catch that? Write that down. If you're using your EE button, and you're using times 10 to the 23rd especially, all right, always make sure your answer, all right, and your calculator, look over on the far right display and make sure you do or you don't have that exponent, okay? So now I have 1 sig fig, so I need to make this 1 sig fig, and here I go. Okay, so now what? How many moles? Sounds like we've already done something like this. Why don't you do this one? You don't need me. You do it. Pause this. Do it. Okay, welcome back. Hopefully you got it. So I do this, and then I have my bar. I'm going to put atoms on the bottom, 1 mole on the top. So I can go 3.4 second EE 22 divided by, notice it's in the denominator, you're going to divide, divided by 6.02 second EE 23. This is my answer. That's a lot of decimals. I only needed 2, so there I go. Okay, so if the particle is a molecule, and it asks how many molecules you have, all right? So go ahead and do letter A all by yourself. You don't need me. Pause this, do it. Okay, welcome back. This is what I got. All right, I put 5.3 moles, 1 mole, molecules on top, so it's nitrogen gas. That is a molecule, so I'm going to use that for my number of molecules, all right? And then here's my answer, and that's how many molecules I have. Remember what I told you earlier? If you're using that EE button, make sure your display does or does not have an exponent in the answer. All right, and now let's look at this next one. How many moles? Go for it. All right, how did you do? This is what I came up with. 7.25 times 10 to the 24th, divided by 6.02 times 10 to the 23rd molecules, and I got 12.043, whatever, and I need 3 sig figs, okay? So what's the name of the game? If you're looking for a number of things, things can be moles, or sorry, things can be atoms or molecules or ions or copper pennies, you would use that 6.02 times 10 to the 23rd is in 1 mole. Please, please factor label. I'll tell you this, on your objective checks and on your quizzes and on your tests, if you do not set it up the way we have taught you, you will lose points. Did you hear me? So make sure you do it right. Well, that is the end of the section. So I will leave you with this thought. Don't wait to be great. I hope this was helpful. I'll see you next time. Bye-bye.